All right, today we're diving into something that could completely change how we interact with, well, everything. Imagine being able to control incredibly complex machinery, not with code, but just by talking to it. Sounds like sci-fi, right? Well, let's look at how AI is actually making it happen. Have you ever noticed that the most powerful tools are almost always the hardest to use? It's a weird thing, right? You've got these incredible scientific instruments, these massive industrial robots, all this capability right there, but it feels locked behind a wall because, let's face it, we just don't speak the machine's language.
And really, that's the whole problem in a nutshell. We humans, we talk with nuance, with flexibility. Machines, they need rigid, perfect, step-by-step commands. And for the longest time, the pressure's been on us to learn their language, to bridge that gap.
Okay, so take a professional oscilloscope, for example. It's a super important tool for any engineer. But if you want to automate even a simple task, you can't just, tell it what to do. Nope. You have to write these specific, often really cryptic lines of code. And that right there creates a massive barrier, basically locking out anyone who isn't a coding expert.
Yeah, this slide nails the problem perfectly. On the left, that's what we want to say. Simple, plain English. Find the frequency on channel 1. But on the right, that's what the machine actually needs to hear. A super rigid command, perfect syntax, no room for error. The whole challenge has always been, how do we get from here to there?
So how do we finally bridge that gap? Well, the solution that's popping up is pretty brilliant. It's an AI that acts like a universal translator, this intelligent layer that sits right in the middle between our words and the machine's code.
They're calling it the AI MCP, which stands for Master Control Program. And really, you can just think of it as a chatbot brain for your hardware. It's not just matching keywords, it's designed to understand what you mean, your intent, and then turn that into a precise instruction that the machine's own software can actually do something with.
Okay, but how does that translation actually work? Let's follow a single command from start to finish and see how this thing pulls off its magic.
It all boils down to 3 really simple steps. First, you, the user, just type your command in plain English. Step 2, the AI translates that into something called JSON, which is just a super clean, organized format that computers love to read. And finally, step 3, the hardware's driver gets that JSON and makes it happen. That's it. Input, translation, action. Simple.
So, let's go back to our original command. The user just types out the request. Find the frequency on channel 1. See? No weird syntax, no code. Just a normal, human instruction.
And here is where the magic happens. The AI takes that sentence and turns it into this really simple JSON message. Look at how it just boiled down our entire request into 2 key things. The action is measure frequency, and the channel is 1. It's totally clear, perfectly structured, exactly what a machine needs to understand without any confusion.
And for the final step, the device's own software driver gets that structured message and runs the actual command the oscilloscope understands. And just like that huge communication gap we saw before, it's gone. The AI translator did its job perfectly.
All right, so we've seen what it does, which is pretty cool. But now let's pop the hood and take a look at the key parts that make this whole AI translator tick.
This whole system is basically built on 3 core pieces. You've got the large language model, or LLM, that's the thinker. Then there's the JSON schema, which is like the rulebook. And finally, the scope driver. You can think of that as the hands that actually do the work.
So first up is the LLM. This is the language expert, the part that actually gets what you're trying to say. And what's really cool here is that the system is provider agnostic. That just means you can plug in an LLM from pretty much anyone. Google, OpenAI, you name it, and it'll work as the brain of the operation.
Okay, now this next part is absolutely critical. You can't just let an LLM run wild and make up any command it wants. That could be dangerous. So the JSON schema acts like a super strict rulebook. It basically tells the LLM, hey, these are the only actions you are allowed to create, period. This gives it essential guardrails, making sure the AI only spits out commands that are valid and, more importantly, safe.
And last but not least, we have the driver. Now, this is the software that already exists for most of this complex hardware. It's the old-school middleman. In this new system, its job is even simpler. Just take that perfectly structured JSON command from the AI and pass the final instruction over to the hardware. It's the final link in the chain.
So, yeah, we've been talking a lot about this one oscilloscope.
But the real power, the real aha moment here, is that this isn't just about one device. Not at all. It's a blueprint for something way, way bigger.
And this is the key thing to remember. This whole framework, the thinker, the rulebook, and the hands, it's not tied to just one machine. It's a universal pattern, a recipe you can apply to almost any piece of complex tech out there. It's basically a blueprint for a universal remote for, well, everything. And it's one that finally speaks our language.
And the potential here is just huge. Seriously, think about it. A scientist could control a whole lab full of instruments with just a few sentences. A factory manager could coordinate an army of robots just by describing what they need done. We're talking about everything from heavy industry to making your smart home routines less of a headache. This whole approach just tears down the barriers to entry, making powerful tech accessible to pretty much everyone.
And that really leaves us with one final big question to think about. For decades, we've had to learn the language of machines. But what happens when that flips? When our devices finally start to understand us? What kind of new possibilities get unlocked? What are we all going to build when the most complex tools in the world are finally as easy to talk to as another person?